Okay guys, so it is the week of April 13th. We are continuing our triangle congruence proofs using today angle, side angle, and angle, angle, side. So this first section at the top we talk about the angles, two angles and then a side being between them. So if we look at this diagram here, we have angle A and angle D. Those two are congruent. And then there's this side in between, AB and DE. And then these angles B and E that are congruent. Okay, it makes those two triangles congruent by angle, side, angle. So when we talk about the triangle congruence statement, you start by picking any order on one of the triangles. I'm just going to go A, B, C. And then I have to go in the same order according to the matchings in the other triangle. I don't care which way you start this one. You could say A, B, C, A, C, B, B, A, C, B, C, A, CBA, CAB. Doesn't matter. There's a bunch of different ways. It literally doesn't matter. You just have to match up in the second triangle. So because I went from the one arc to the tick mark to the two arcs, I have to go one arc, tick mark, two arcs. So triangle DEF. Okay. All right. Some sample proofs. I'm not going to do both of these here because on the next page it kind of picks up the pace a little bit, and we actually want to get through another one of these congruencies tonight, or today I guess, so I'm not going to do a whole bunch of these proofs. I'm just going to I'm going to post the answer key and I'm going to let you ask questions if you have it on our Zoom meeting on Wednesday morning. So number one, we're using side angle side here, okay? It gives us that segment SQ bisects angle RQT. So segment SQ bisects angle RQT and angle RST. It was up there too. So that reason is given. We can get some stuff from that bisector. When you cut an angle in half, or when you bisect an angle, you get two congruent angles. So it says that SQ, this horizontal segment right here in the diagram, bisects angle RQT, this big angle on the left, and the angle on the right. So those angles become congruent, the two pieces become congruent. They don't necessarily become all four congruent to each other, but the two pieces on this side are congruent to each other, two pieces on this side are congruent to each other. Okay? Numbers 2 and 3, those statements say angle RQS is congruent to TQS, RSQ is congruent to TSQ. So that's just saying what we marked in the diagram. You have to be explicit. It's like giving directions to someone to get to your house. If you miss a step, then they're not going to make it, right? They're going to end up lost. So you have to be very explicit and say, even though we know that you bisect an angle, you get two congruent angles, you have to specifically say it. Okay, so the reasons for these are going to be the same. If bisect a segment, then, so what did we have? We had a angle, oops, that's wrong. We bisected an angle. See, this is why I go back and double check that I'm using the right words here. So what did we have? We had an angle bisector. So if you bisect an angle, then what did I get? Two congruent angles. Okay. That's if you're going to use the if-then statements. If you wanted to just say definition of an angle bisector, these two statements are equivalent. Either of them will work. You could use one and one. You could use both of the same. It doesn't matter to me, just so long as you can get your point across. Okay. The next thing says segment QS is congruent to segment QS. QS is this piece in the middle. It's congruent to itself. You do have to mark the diagram. When things are congruent to themselves, segments or angles are congruent to themselves, that's called the reflexive property. Okay, that's your reason. It's reflexive. All right, now if I'm looking at the diagram, I have an angle, a segment, and an angle. Segment is between the two angles, right? So that means that those two triangles are now congruent to each other. That's the prove line. Always the last step is what you're trying to prove. We are going to say that these two triangles are congruent to each other by angle, side, angle congruence. If you want to list the steps in order, the first set of angles came from step number 2. The set of sides was step number 4. And then the second pair of angles was step number 3. It does have to be in that order. You have to put the 4 between them because it goes angle, side, angle. Okay? All right, just a little reminder down here in number 2. I'm not going to do this with you, but this means parallel. We are going to skip that one because you guys need to know those parallel lines cut by a transversal thing again like we did last week. And we haven't done that. You'll do that in math too. So we're going to skip that one. Number 3 is talking about a midpoint. It's saying there's a pair of congruent angles, and then it's saying that this C is the midpoint of AE only. I'm going to tell you right now that the midpoint means that you get two congruent segments, but only on the one segment. So only on segment AE. So AC is congruent to CE. Okay? All right, the rest of that is on your own. Okay, the next type of congruence that we've got is angle, angle, side. So we need two angles in a row and then a side on the outside of those, or on the end of them. Okay, so we could say A is congruent to D, and then we could say B is congruent to E, and then we would say BC is congruent to EF, and we would have angle, angle, side. I'm not going to fill this in because you're going to get the answer key in a minute anyway. Okay, so now here we are stepping up our game a little in terms of writing our proof. Up to this point, you guys haven't really done a proof where you have to write the statements and the reasons. You've only had to write the reasons. Okay, we always start writing the givens in separate lines. So there's a comma here that means there's two givens. Segment YZ bisects angle WYX. YZ bisects, I'm going to abbreviate bisects as BIS. Angle WYX. My second given is angle YWZ is congruent to angle YXZ. Okay. My reason here is for both of them given. That was information we were given. Okay. We need to go mark the diagram. Number 2 specifically tells us a congruence statement, so I'm going to jump to that one to mark the diagram with that. YWZ. YWZ is this angle right there. Is congruent to YXZ. YXZ is this one on the right. We mark those the same. Okay, when we look at this statement number 1, when we bisect an angle, we get two congruent angles. Okay, so we are going to bisect WYX. I am not done with this piece of information. I'm going to continue the information down here until I get a congruence statement out of that. Okay? So I bisect an angle, it means I get two congruent angles. YZ is bisecting WYX. It's bisecting this big angle at the top. So I'm going to get two congruent angles at the top. Okay? Those angles are WYZ, WYZ, and angle XYZ. If you said this angle in a different order, that's fine, just so long as Y is in the middle. Our reason here, what did we have to begin? We had an angle bisector. So if you bisect an angle, then what did we get? We got two congruent angles. So then two congruent angles. Okay. It's giving us two more steps. Our last one is always going to be the prove line. So this last one is going to be prove. triangle WYZ congruent to triangle XYZ. Okay, we need something in between it though, because as of right now, I only have two angles, two pairs of angles congruent to each other. We're looking for angle, angle, side. So here's my two angles. In those two triangles, I need a side that's not between them. I cannot use, and I don't know anything about the relationship between YW and XY. So instead, I'm going to use this reflexive piece, YZ, congruent to itself. So segment YZ is congruent to segment YZ. I'm going to mark it up here in the diagram, and now I very clearly have angle side, or I'm sorry, angle, angle side. Okay, my reason for that one was reflexive. Okay, hold on just 1 second. Okay, so I just paused the video for a second. I'm sorry. I had somebody come to the door. Okay, so at this point we have an angle, and a side. That's enough for us to say that the two triangles are congruent, and I'm using the congruence or the prove line right here. I'm not reordering anything. I am just copying it letter for letter. There's no point in trying to reorder. You just put it in the way it's telling you to put it in. Okay? So triangle WYZ is congruent to triangle XYZ, and that was angle, angle, side. If we're looking at the step numbers where we got those congruencies, the first pair of angles was in step 2, second pair of angles came from step 3, and the pair of sides came from step 4. Okay, cool. Next page. So these three on this next page, 5, 6, and 7, again, we've got some stuff going on with number 5 and 7 about the parallel lines. I'm going to tell you to skip those. If you want to look at the answer keys for those, and just so you can kind of get the idea, you're not going to understand the reason behind all those angles, how we get these angles congruent there because of the parallel lines. But if you can kind of follow the process, that's really the most important thing. I would say number 6, you should be able to follow that one because it's very similar to what we just did in number 4. Okay? All right. Again, we got one more congruence, type of congruence that we're going to do, and then we'll be done for tonight. So we're going to flip one more page. We are talking about right triangle congruence. So this one, remember, this is the one that a lot of people just use HL. That's the one I like to say RHL because then it's the 3 pieces that you need to have. So you need to have the right angle, the hypotenuse, and the leg. Okay? So when we look at that, if we wanted to say right angle, hypotenuse, leg, the abbreviation again, RHL, cool. Here's our right angle. So you don't ever need to say those right off the bat necessarily, although when we're doing proofs, I think I usually do. Maybe. We'll see when we get through number 1. Okay, so the hypotenuse is always across from the right angle. So this is saying BC is congruent to EF, so that would be there. And then the leg would be AB is congruent to DE. There, and then you would write your triangle congruence. However you line this one up, whatever order you put the first one in, you have to put the same one, the second one in that same order with the matching angles and sides. Okay. All right. So let's do this proof here and see what we get. It says as a given, we're back to having some givens written or statements get written in for us. Triangle LMP and triangle MNP are right triangles. Perfect. Given. Whoa, forgot the I there. Okay, so that was given. It also says segment ML is congruent to MN. Okay, ML is here, MN is there. This one, the way that this is set up, normally when we are doing these proofs, I would not necessarily I guess it's important that it's here, but I would maybe go a step further and say that the right angles are congruent, but for the purposes of this is totally fine. You've got these right triangles, so you automatically have the right angles in both. If you weren't sure where the other right angle was, whenever you have perpendicular lines like this, the right angle is on both sides. Okay? The next thing that it's saying is that MP is congruent to MP. We've done this several times. MP is in both triangles. I'm hoping that you guys remember the word that we use for that, and it's congruent to itself. It's reflexive. Okay? We're at the point then where we can say that those two triangles are congruent to each other because of RHL. Okay. So triangle LMP is congruent to triangle NMP, and it's because of HL, or like I like to say, RHL. In terms of steps, the right angle part came from step 1. The hypotenuse, the two hypotenuses, ML and MN are in step 2, and then the legs came from step 3. Okay. The next one, let's see what else we have. Okay. We're going to do one more like this because it does not have the statements written in. So I'm going to give you one more example for the notes, and then I'll talk real quick about the homework. It says triangle WVX and triangle YZX are right triangles. So triangle WVX and triangle YZX are right triangles. That was given. Okay, now this is kind of important. Okay, it says that they're right triangles, so we kind of need to know which one of those three angles in those triangles are right angles. Okay, the diagrams are probably not drawn to scale. If I were to guess, though, I think that it would be V and Z are my right angles. They kind of look like them. You remember the trick when we were in school where I put the corner of the paper in there, and look at that. It lines up pretty well. So I'm going to say that the right angle is V and Z. It also tells us this piece of given, WV is congruent to YZ. WV is congruent to YZ. Okay, those are adjacent to the right angle, meaning next to the right angle. They create one side of the right angle in each of those triangles. That makes those the legs. Okay, so we've got a right angle and a leg. We're looking for a hypotenuse so far. We have a third given. X is the midpoint of segment YW. So X is midpoint, I'm abbreviating midpoint is MP of WY. I forgot my reason up here was given. This was also given to me, so I've got three givens. So X is the midpoint of segment YW, or WY. That's this one here. So X is in the middle of just this segment. That midpoint means that the two sides of it are exactly the same length or congruent. So I need to go a step further past the midpoint and say specifically that those two segments are congruent. So WX is congruent to XY. And it's because what did we have? Midpoint. Then what did we get? Two congruent segments. Okay? If you wanted to say definition of a midpoint, that's 100% acceptable. Okay. We are at the last box here, so that's a pretty good indicator that we should be done. Let's just come up here to the diagram and double check. I have a right angle. The side across from the right angle is the hypotenuse. And then I have one that's adjacent to the right angle. So right angle, hypotenuse, leg. Right angle, hypotenuse, leg. So we do have RHL, which means that we do have those two congruent triangles. WBX is congruent to triangle Y, Z, X, and it's because of RHL. Okay, my statements or my reasons, step numbers would be 1. The hypotenuse came from that midpoint thing, so it's actually step 4, and then the legs was step 2. Okay? Okay, so in the blank document that I posted in this same, where the video is, the next page, the next 2 pages are your homework. It starts Unit 4, congruent triangles. We're actually in Unit 7. This is not really from MVP, so whatever, you guys have probably figured that out at this point. It's homework number 6, proving triangles congruent, ASA, AAS, and HL. Okay, it's a 2-page document. You are going to do problems, yeah, okay. You're going to do all of them except number 2 because it's got that parallel line thing in it. So you're going to skip number 2, but you're going to do the rest of them. So 1 and then 3 through 6. You can do 3 through 6. The nice thing in number 6 is that it gives you the exact right angle, so you don't have to guess. Okay? All right, so your assignment that's going to be due on Wednesday is this page and the next page. You can do it on a separate sheet of paper and just write your answers. You should try to draw the diagrams, however, okay, so that you can mark them as well. Take a picture of your work and then post it to Canvas. Or if you print these 2 pages, you can do the work right on here. Make sure you're marking your diagrams and then post those pictures to Canvas. Okay. We'll be on Zoom on Wednesday morning. If you have questions in the meantime between Monday and Wednesday on our Zoom meeting, you can feel free to email either myself or Mr. Fredericks.